I could have forgotten. All right. So, all right. So, yeah. So, external table is like a symbolic link. If you delete the link, the actual file remains as is. If you if you are deleting the actual file, the data also gets deleted. So that's exactly the difference between uh, external table and a normal table. All right. So I hope I made it very clear to all of you. Great. Great. So, guys, there are few questions which are really interesting, which I have recently posted on through the forum. Okay, so stay tuned onto the forum and be active on the forum. And we are planning to basically give you know, give a kind of a score to all our students on the forum, so that I'll just show you. So, for example, some of the candidate was this was actually a very good question, and it's a great recipe for the interview. So where is my map reduce here? All right. So the question to a question in that a question to all of you can be in an interview that what is wrong with our usual map reduce? Everybody whosoever learns about Hadoop talks about our word count example, right? Everybody in the world talks about the same word count example. Now, the question is that in what circumstances will word count fail? Okay? In what circumstances will the word count fail? Did anybody think about it? So, in our normal word count, all we did was we created a mapper which basically broke in the line into words. And so, line one was fed to one map function, right? Then line two was fed to another map function, and so on, right? So this way it went on. And this line 1 and line 2 were separated by new line, and mapper gave out the list of pairs of pairs of each word in line and one. Okay? Or you can say something like word comma one, then all right, that's what our mapper did, and a reducer basically summed it up. So, do you think there is a problem in this? In what circumstances will the word count fail? Next time I'm going to interview somebody, I'm going to ask this question. Anyone? The usual word count example, where we break the line into word, comma, one, and in reducer we just count it. Nothing comes onto the top of mind. All right, just go through this discussion. Uh, so, okay. So basically, every time he executes his program, all he was getting is all he was getting is a Java heap error. Okay. So the problem was if the line is too big. Okay. Imagine that there is 2 GB file. Okay. Having having no new line character. Having no new line character. So each mapper will there will be only a single mapper in which there will be 2 GB of memory consumed. All right. In this circumstance, the mapper will pathetically fail and will give the memory overflow. Okay. Now the other scenario could be this is first scenario in which the usual word count will fail. The second scenario would be if there is only a single word in the whole file and the file is bigger than the RAM of reducer node. So if you imagine this, if there is a single word which has come around say a billion times, which means uh, a single word with a billion key values goes to this a single reducer in a single time, and therefore it will overflow the reducer node, correct, because there'll be only single word with all these values and hence it will overflow the. So that's what happened in his case. What he did was he generated a big file with three words being repeated again and again. He generated around 400 500 MB file. So okay, and that's the reason it failed pathetically. So in these circumstances, how to resolve this? The next follow-up question would be, how would you resolve such problems? Okay, these are real questions which people face. So stay active on the forum. Go through the questions. These are actually pretty good questions being asked by people. Okay, and if you have even if you mail me the question, most likely I'm going to put it on the forum only and reply there. Okay, so is everyone with me? Great, great. All right, all right. Of course, Amish. It will be available after the class ends. Yes. No, Ingoba. The answer I have given is have a look at the answer. Have a look at the answer which I have given on that forum, and that should solve that. Okay. All right. Great. So we are starting now our discussion on the data model of HBase. The most important thing to understand in databases is the data model and how would you fit in your requirement into data model. All right, we had already discussed this part, the importance of. All right, so we described what is a row and what is a row key, and we also described what is a column family and what is a column, and then cell and the versions of each cell, right? And this is how it looks like when you look at it from the physical perspective. Okay, now let's take a case of Google or any search engine who wants to store their data into really big database. And for that matter, the only reason Google wrote big table is for their crawl corpus, as in the content of the crawl data. Okay, so if you look at this table, okay, now I will go one thing at a time in this table. One is there is something called a row key here. So let me first describe what is it that this table looks like. Okay, so what does this table contain? So every time Google hits a website, it um, uh, every time Google hits a URL, or we call it website, it downloads the data of that website, finds out finds out all the links which this website is pointing to. Say if you go to our website, it's pointing to some pages locally itself, as in nobigdata.com's pages, as well as there will be references to Hortonworks, there will be references to Hadoop, and there will be references to HBase. So then it will find all these URLs to which our website is pointing to. And then, other than storing our content, what it will do is it will also start crawling these websites. And once it hits the website, it will do the same thing again and again for all the websites. And this way, and it also makes a note of who is pointing to who. Okay. So, how it is. So in this schema, there is an interesting way Google stored the data. So for each website, they created a row. The URL, was the row identifier, because each each website has got a distinct URL. All right, and each website has got a distinct URL, and website has got various kind of content. Content could be HTML. The inside a URL, it could be PDF. Okay, so it created two kind of column families in this table. So each row has two column family. One is called contents, other is called anchor. So content has the default content, the column name with the empty name. The column with the empty name is used for storing HTML content. In case there is a website which has data in PDF, it will create one another column called contents colon PDF, and so on. Okay, and in column family called anchor, every time a website is referring to somebody, it adds a column, which means this table is going to have millions of columns, right? because for each website being referred, it's creating one column, right? If my website is referring to hundreds of other websites, so what it will do is, for my website, there'll be one row, and for each link my website is referring to, will create those many columns, right? So if we will see why they are doing this way. So all of these links which my website is pointing to has got one column reserved for them, and the column name is the URL of those websites. Now you can see few things which will irritate if you are a DBA. First first, column has got a name called and the name is URL. A name is not an ID here, is not a number, but it's an identifier. All right, and each column is being used like a data store. Each column name is being, if there's a column, there a URL which is in Chinese, or it has got say 200 characters in it, it's completely okay to keep it as a column name. All right, and the actual cell name contains very rudimentary data. And what is that rudimentary data? The name with which I'm referring to some website. So if my website is saying ahref equals to hortonworks.com, and then inside, between the opening and closing tags of a anchor tag, between those tag I put that the definitive source of Hadoop installer. Okay, so definitive source of Hadoop installer will go as here. So now in this schema we have the CNN.com is pointing to CNNSI.com. It's referring to them, and it's linking CNNSI.com by this name, meaning this is CNN is what the user sees on the website. And as and when the CNN.com keeps on adding more and more links, and Google notices it, Google will keep on adding more and more columns into it. All right. And in case the text is being changed, it will basically create different versions for it. No, there'll be a single table for the whole website. All the websites will have a single table. Each row, each row is for one website, one URL. Okay? It's like if you guys have seen people who maintain a Excel sheet for discussions, and they keep on adding more and more columns as and when more and more uh, discussions are happening on each item. Correct. So yes, Vikas, each row can have different columns. Now Ramesh's follow-up question is, then how can the columns match? Why do columns as in, do you mean that when we'll do the join, how will we do the join on the basis of columns? Is that your question, Ramesh? Yeah. So if that is your questions, now Ramesh's question is, there could be so many different links to another website. Yes. So see, in these scenarios, when you talk about this kind of data, you do not think about joining on those ideas. To do that kind of operations like joining or any other magical operations, you use MapReduce. Okay. So all right. So Vikas's question is that, uh, when it is so dynamic, how do we define the table in front? The answer is we don't. As I was telling you, the only thing you have to define is the column family names, not even the data types of column families, just the names of column families in the table. That's all. And when you are adding a record, you can choose to put a column inside a column family, okay? Or you can just ignore. So we do not define the columns in the table up front. We just say that these are going to be the column family names. That's all. Correct. That's correct, Ramesh. So CNN.com will be one, www.cnn.com will be one row in this table, and MSNBC will be another row, CNNSI.com and NoBigData.com and all those, every every URL is going to be one row in this table. Yes, but the links will be not be same. So these are very valid question, and it's good that you are asking these questions, and that's exactly the reason why we're discussing. So one row and another row can have totally two separate set of columns. And that is the whole idea, and that's the whole reason why NoSQL is called NoSQL, because these are not very uh, schema things. I mean, you don't have schema for these. Okay, so the way so if you have same column name, it's well and good. If you have different column name, that's also is a well and good. Okay, all right. Any doubt about this? So Vikas's question is, so during table creation, we mentioned one column family for contents and one column family for anchor. So the second column family can have n number of anchors, correct? And also the first column family can have 100 number of columns upfront. Okay, so So should I give a demo before getting into this example, right? I think that'll be better because that'll give you a little bit more idea about what we're talking. Yeah, I think I'll just mention in this slide also that in future we'll just give a demo before we go ahead. So let me just log in and also parallelly check if our Ambari is up. All right. And this is bad. So let me just see. None of the region servers are live. I'll have to log out. And the irony of the situation is that, all right, just give me a second, because if I turn off my screen, then the recording will get corrupted. And in case I don't turn off the screen, also I'll just parallelly start another recording. All right, and so let me all right, let me just start the region servers. All right, so we have started the region servers, and let me start HBase shell. So just like we have in HDFS or everywhere, we have here also something called HBase and region servers. HBase master contains the index of things, and region servers contain the actual data. We'll come back to the architecture a little while later. And yeah, okay, so here, okay, let me just go back here. All right, so now we can see the status. So all I did was HBase shell is what we have started. What does it say? Okay, so, oh, sorry, I'm not even logged in on to SSH. That's the reason. It's my local machine. And I'm wondering what kind of errors are. All right, so I've logged in into Hadoop 1, and the way we start interacting with HBase is by launching HBase shell. All right, and there we have status, and status here should show that 3 servers, 0 are dead, and everything is up. And so we can, let's say we can create, or let's just type help. So you can go through these list of commands. We will just focus on a very subset of the whole thing so that you get a fair amount of idea into these technology. And say in HBase, what we want to do is we want to create a table. Create, and we say table name. Say what do you call it? Crawl corpus. Okay, crawl corpus. We created a table called create this thing. Then we can say my first column is contents. Second column is second column family is anchors. Okay, so it has created the table, and we can see the list of all the tables, and here is our crawl corpus. Okay, and if you say that scan crawl corpus, then you can see that this is the okay, and there would be one table underscore help. All right, so we can say all right, second set list. So we have got this table. We have created one table with a group. Now we can say that put into crawl corpus. Okay, and after that we will be basically saying that create a URL, and here we are going to say com.google.www, or com.cnn. Sorry, here this is our row. Okay, then we specify our column. Our column could be okay, contents, and in the contents we can mention one column name, nothing, no column name, and the value could be our HTML and some HTML, and that's it. Okay, so in the same row we can add more and more things. Okay, we can say anchor. We created a table column family called anchor, right? And this column family is referring, say, cnnsi.com as CNN. Okay, so yeah, this is correct, right? So we say table name, row name, column name, and then, yeah. So anchors was our, so if CNN.com is pointing to say, ouch, okay. So if CNN.com is pointing to say MSNBC as MSN website, then this will be another key value. Okay. So scan crawl corpus. Ouch. All right. So yeah. Now Sandhya's question is why it says 0 rows after you have done that. So yeah, because the row was already created. We just added this into the same row. Okay. What happened earlier? I want to see. So yeah. So the first time we created a row, I'll show you that. First time we created a row. Okay, now you can see. Yeah. For the first time, we created, we put the first data called contents with a fresh key, not here. Uh, for the first time, it would show you that it has created one row. Okay, now it says that it has created one row, and this is our row key, and these are our values. So you can look at this kind of a representation, and you will see that it looks like a key value pairs. The row is, there is key and there are values. See that? So here it says that row ID is www.com.cnn.ww and column is this. Okay, and so on. Make sense to you? Now, let's add some more data to this. All right. Now, maybe there is another website called No Big Data. Let me just edit it in here. No Big Data. And for that, there'll be something called contents. And let's say this time we are not adding empty, we are saying PDF. Here for PDF, there'll be some binary content, okay? Some binary content, hexadecimal content, okay? Ideally, it'll be a binary one because right now I can't demo you that binary one. So, and this will be calling, maybe it's calling, say, cloudera.com, okay? Vendor old, and we are referring to that vendor like this, and maybe this we are also having some references to MSNBC, and then we are having some reference to Hortonworks, okay, or okay, and so all right, so maybe we are referring to like this. So now you can see that the column names can be different in. So anchors means another website. So it's up to us, right? Here in our schema, what we have said is anchors is our column family in which we are adding. So there is one column family called contents in which we are adding one column called PDF. For this row, we are adding this column into column family, and we are adding some binary data. Okay. Similarly, we are adding basically into a row called a table called crawl corpus. Into this row, this particular column called cloudera.com, new, this is a new column because it doesn't exist already, and into this column family called anchors. And where do these anchors and contents come from? The way we have defined our table. If you see the way we have defined our table, where is the, yeah. So we defined our table crawl corpus with these two column families. Make sense, Kalyan? So create this particular table with these column families. Okay. Now, if we try to say, imagine that here we are trying to add one more column family, it will immediately throw an error to us. Okay. It says that it's invalid. Okay. It gave immediately an error to us. Okay, it says column family contents 1 does not exist in this particular region. Perfect. Great. Now we are adding one more row into our column family. Okay. Interesting thing is that it says 0 rows in this table, even for the first data. There is something unexpected. Basically, it did not result in any output. That's what it is saying. This particular command is has that's I think that's the only reason for 0 rows. Okay. Now, so in Goba, is everybody able to hear me? Yeah, great. So now you can see that. So we created these rows and this data. Sounds good to you? Any doubts here? I know there are doubts, so please ask. It's actually only one row, is the way it has presented the data to us. Ramesh, it's actually only one row. So we can actually say get from this particular table, and we can say we can give a column ID no big data.com. Just a second, is that what we did? Did we not put it correctly? com.nobigdata.com. Did we make a mistake somewhere? Yeah. Oh, it has to be ww. Okay. Yeah. So Aruna's question is that, okay, great, great. So Kalyan's question is, so while adding a row, it's not mandatory that we specify that for all column. No, not really. Okay. While adding a row, you don't need to specify the columns in all column family. You can pick any column family or more than one column family, but you cannot create a fresh new column family while adding the data. Now, next question is from Aruna. So there aren't really any data types. No, we don't define any data types upfront while creating the table. We just define we just define table name and the name of all the column families it is going to have. And one column family or one column can have, say, let me just show you that. So let's say we created this, okay, and there is, let's say here, okay. So let's say there is another website called, say, Microsoft.com, Microsoft.com, okay. And here in this actual data, in the actual cell, in the same column, can have a different data type like numeric 1, okay. Yeah, it has no problem whatsoever. In the same column, it can have different data type. While this particular row, which was having no big data's data, had in this column string, while for here in Microsoft's case, this column has only a numeric value. Okay. So in case you are using a select query or something like that, on the runtime, you will get an error for those records. Now, a question from Kalyan is, why do we need to store the key in the reverse? So this problem is specific, this data model is specific, and we are actually exploiting a feature of HBase where it's storing the key in a sorted manner. Okay. So since row key since the whole table is ordered by the row key, in order to ensure that the same URL or the subdomains of the URL are nearby, that is why we are keeping it like that. Now look at this. So imagine that we had another website called blog.nobigdata.com, right? These two, since they are lexically, this URL and this URL are close by, right? So therefore, that is why we are keeping it inverse. If you imagine that we had two websites, blog.nobigdata.com, www.nobigdata.com, and had this been our Microsoft.com, blog.microsoft.com. Now, if you see, if these are sorted, right? If we sort this data, so first no big data will come, then Microsoft, then again no big data, then Microsoft, right? That is why we have inversed it so that when these records get stored physically, they are nearby for the same domain. Okay. So, all right, this is very, very important aspect which we need to understand clearly, and maybe we need to address it again. Okay, so all right, sounds good to you. Now, So everybody, so when we talked about last time, when we talked about data model, the very important aspect was it's a a sorted list of things, meaning the data is ordered by row key. Yeah. So the data is ordered by row key. And so in order to basically, whenever you're planning for storing huge data into HBase, you always plan your row key such that the data you need to access all together should come together. Okay. So here we needed to, all we wanted is all the URLs, all the rows which belong to no big data or Microsoft, they should bunch together instead of one getting into another. So as we give an example, now if we stored our row just like this, our row keys were normal URL like this and like this, then then when you sort this data, this row key could have come first, then Microsoft, then again no big data, and then my imagine there are say 10,000 entries. Okay. So it will be difficult to just go to no big data's all URLs, right? You'll have to scan all of them. But since we have reversed it, all of them will come together, because if you see here, if you try to say, let me just copy this data. Let me try to copy this data. Okay. Now this data, no matter how you sort it, right? Okay. Now you see, no big Microsoft did not get into the way. Why? Because first, the way we have represented is reversed it, and therefore blog.nobigdata.com will come very closer to www.nobigdata. So we can quickly scan all our data. So how does the program determine which data goes to which column automatically? Now, if you look at the way we have done here, so we are saying in each of the put statements, in the put statement, we are saying put into this table, right? Into this row key, into this column family, into this column, and this is my data. Make sense, Lingli? So every time we are inserting some data, we specify all these parameters. Table name, row ID, column ID, yeah. Okay. So Lingley's question is so the way we are doing right now, programmatically also we will be doing in the same manner. We'll not be doing something like insert into table and values are this. Okay. This is not we are going to do. Okay. That's something HBase doesn't support, but there are wrappers who provide you these kind of functionality on top of HBase. Their API would check and try to find out the column names whenever required. Did I make sense, Lingley? All right. All right. Now, Kalyan's question. In real time, the column keys will be same always for one row key. So in real time, the column keys will be same always for one row key. No, you can delete a column. You can delete a column. So for each column, each row, you can keep on adding as many columns you want. So you added one column just now for one row. You can keep on adding more and more columns. The way we have added multiple columns just now into one row, we can keep on adding the same way as many columns as we want. Okay. So if you can see that here for this com.nobigdata.www, we have added first column called cloudera.com, second msnbc.com, the third hottenworks, and so on. Okay, we can add as many as column as we want into one row. Kalyan, was that your question? No. Okay, here the anchor shows. Correct. So no, here the anchors means on our website, on No Big Data website, the page would be containing something like the page, the No Big Data here. This page would be having, so No Big Data's page would look like something like HTML, blah blah blah, and then end of HTML, and inside the body tag, you will have things like a href equals to ahref equals to cloudera.com. Okay, cloudera.com, and then we'll have close ahref, and then there'll be something like vendor old. Okay, now there could be another href somewhere on the page called msnbc, where msnbc would look like this, and msn website would be. So this content, this is the HTML content, and this content will be inside here. Okay, this will be content inside. Say, it'll look like. Okay, so I will put it this way. Okay, I will put it this way here. So since we have chosen empty column name for our usual HTML data, so it will look like this one. Okay, so it'll look like this one. So in this table, for this row, the empty, empty column, which is not, we have chosen for HTML data, is this one. Okay, great. Correct. Correct, Ingobin. So now there was a question from Ramesh. Is it fair to say these are not really columns as in RDMS columns, but really column families, and every entry into column family will have a name? Correct. That's how you can look at it, Ramesh. That's correct way of looking at it. Great. So everybody comfortable with this model? So yes, Aruna. That's the reason. So this data model was created by Google and by others also in order to solve their big data issues. Okay, because whenever you hit into the example we gave you right the other day, every company who started daring into handling big data, They ran into exactly same scenario. And trust me, it was not only the Google who came up with this kind of structures. Companies like Amazon and other companies also came up with the similar structure at the same time, realizing that they have to solve their own problems. Okay, so uh, similarly, you will have to create your own data model. Imagine that imagine that you are building an email service. Okay, you're building an email service for your organization, which is going to handle billions of emails every year. Okay, and it should not have any problem in storage of the data or the retrieval. All right, so there are many use cases, I mean, wherever you have to handle a data beyond a certain capability, and data has got some structure, not really a strong structure, but it has got some structure, then you generally choose to go with HBase. All right. If you have you have no clue about any structure in your data, you just put that data into HDFS. In case you have got some idea that this is how my records are defined and I want to manipulate one record at a time, and my requirements of editing the file or editing the records is really high, then in those cases you go for HBase. All right, so everybody with me, or have I lost you? Great. So each row key is a reversed URL. The reason being, as we told you the other day, this big table is nothing but, all right. So here you basically, whenever you deal with this data, so sorry, I'm actually disturbed by, okay. Now, Incobin is saying, can you please repeat the HBase comment? All right. So coming again. So whenever whenever you have to handle big files where your requirement is mostly append only, okay, then you go for HDFS. But if you have to have uh, figured out some record based manipulation, okay, or your editing requirements, editing a record is really high, then you go for HBase. Okay. Imagine that in our say 500 GB file, each line has to be edited very frequently. Each line has to be edited very frequently. So in those cases, you do not go with HDFS. You do not go with HDFS. Instead, you go with the HBase, and you just define a single column family with single column, and you just add one column called my line. That's all. Okay. So, all right, that's how it is generally done. So, row key is a reversed URL. Reason being, our table is sorted by the row key. So, and we our requirement is that we would want to access our data from a single website frequently together, right? And therefore, it makes sense to reverse the URL because it's lexically sorted or binary sorted. Therefore, it makes sense to reverse the URL and then save it. All right. Now, In the above example, how HBase decides which is the content for contents column family, and so it's based on this colon. If you see the colon, so colon, you cannot use colon in the name of column family anyway. Okay, and therefore the colon is considered as the separator between column family and the column name. Make sense to you? All right. Ouch, looks like my computer has hanged. All right. So how would they decide on a particular database or program in real work environment? So Kalyan, was he able to answer your question regarding uh, so okay, so but when we are searching this site, the above rows will be inserted. Correct. And also, so what will happen is there will be two things happening parallelly. Crawler will keep on crawling the data and inserting these rows. Then there will be some parser which will understand the HTML and will keep on inserting the columns. Okay. So there are high chances that the columns are added later on while row was created at some other time. So the chances are that in this one, first some this one was added, okay, then another row will be added, and afterwards some other program will parse the data, understand which are the href, and then these things are added. Okay, is that what your question is? No, this is not us who is doing. So it's a Google who is doing. Google will basically crawl the data at their own frequency in the backend and will get the data from you and keep it in their database. When you are searching, then it will immediately look it up in their HBase and give you the results. Okay, so basically, they will create something called inverted index of the documents so that you can quickly search. That's completely different. So the searching happens from their text. It doesn't go onto the website and then search. Okay, why they keep on in the background, keep on collecting the data, keep on building uh, this kind of a corpus, and when the user comes and searches, they basically look into this index. Okay, so these rows are not added when you are searching. These rows are added when Google visits your website, and Google does not visit your website when people are searching for it. Google keeps on doing it as the housekeeping work continuously. All right. Now, Aruna's question is, how would they decide on a particular database or program in a real work environment? So, there are, this is a very difficult question to answer. That's why I have kept my last slide for exactly this reason. And in the 10th session, we will discuss this part. All right. Should I move? All right. Now, so we already described all of this. Each value here, this CNN. Tomorrow, if you're referring to the same website with a different name, then this value will get changed and will have a different value, and will but the older value will be pushed into the older version. It will not be deleted. All right. Okay. So again, the same thing for each row key, and there'll be timestamp, and then there'll be all these values. And for each, basically for each cell, there'll be many timestamps. By default, there are last three values are stored. So you can exploit all these properties of HBase. First is row keys are sorted. Second is that you can add as many columns as you want. Third is that you can add lot of data into the column names itself. And fourth is that into the cell, you can actually store you can actually store the various versions of the value. If you are changing it, the previous versions are also retained. So you can utilize this version specifically. Version can be utilized in resolving the conflicts. Say multiple people are editing a cell simultaneously, and based on these various versions, you can resolve the conflicts. Okay. All right. Okay, so there are few design guidelines. First is the indexing is based on row key. There is no other indexing. If you want to create indexing on another column, a better idea would be to have a separate table which says that which basically has the rows based on another field. Okay, so so there is only one index. There is no such thing called secondary index. There is only primary index, and tables are sorted based on the row key. Each reason, so the way we define a reason, so before we move forward, each table is broken down into reasons, and each reason is internally, this is internal. So whenever you have a big table, the the table is sliced horizontally and will be put into multiple reason servers. Okay, and these reason servers will have the a section of the whole table, and whenever we are querying the HBase master, it will redirect us to read from each reason servers. All right, initially there'll be a single region server allocated to your table. If you have, say, initially only one row, there'll be only single region server. And as and when the table is growing, the table is split into two, and first part stays on this machine, while second part moves on to another region server. Okay, and on what basis this division happens? This division happens based on the row key. Okay, so each region is defined as the row key start, row key end, and while start key is included in this region and end key is not included in this region, that end key will be in the next region. So if I'm saying that my region server contains my table has got 20 rows, first region server contains the rows starting from A to K. Okay, that means K is not in the first region, it is in the second region. Okay, this is how you generally define any ranges, okay, inclusive and exclusive. Okay, I missed a question from Lingley. Also recording how many times a visit is coming from a particular referring URL. Correct. So, so those kind of statistics will also be stored in the same table. All right. Those kind of statistics will help Google compute the page rank. Yeah. So, Kalyan, are you talking about what could be the requirement for the above example? Which example are we talking about? The HBase example which we gave? Yeah. So the there are many requirements. Whenever you are storing humongous data, it has got some keys, right? So you always, instead of visualizing only data as rows only, you visualize the data as a big matrix, big sparse matrix. Okay. And say email, we will, that's anyway assignment. So imagine that you have got a, say persons, right? Say there are lots of people across the globe, and we have decided that you are launching facebook.com, and people can define their profile information. You can define name, but you cannot define the first name. You choose not to define various aspects, and you keep on adding. So HB in the Facebook would be storing all of this information into one column family. Okay. And even all of your, as and when you are posting something on your Facebook, it would be maybe it is just creating one more column in the table. Okay. It's just creating one more column in the table whenever you're posting something. All right, coming back to the discussion. So, whenever you have a very humongous table, it is basically divided into regions, and each region is defined as start key, end key, and the atomicity is guaranteed at a row level, meaning transaction is guaranteed only on a single row. Meaning, if you are editing a single row, the intermediate data will not be visible to anybody and will follow the consistency rule, as in no two persons will be able to corrupt the same data. Atomicity is guaranteed. But there is no such thing called multi-row transaction. The kind of luxury was provided by RDBMS. It's not there here. Okay? There's no multi-row transactions. You cannot say something like add one row and then add another row, and in case the second row is successful, only then first row will be committed, otherwise. So those kind of things are not possible, but you can emulate those by the help of a single row transactions. Okay. In column families, all right, so column qualifiers are dynamic and can be defined at creation time, meaning which we have already defined discussed earlier. And whenever we are retrieving data from a table, our data is retrieved in the following manner. First is in the sorted order by these columns. The data will be first sorted by a row key, then the column family name, then the column qualifier name, and then the timestamp In case of timestamp, the order will be descending, while for rest of it, the order will be ascending. Now, you might ask that column qualifier as well as row key can be the binary data. Then how would it sort the binary data? The answer is binary data can be sorted very well, right? There is no issues in sorting binary data. For example, if we have 001 and 0010, and you have 001001, so and so on, right? So you can sort the binary data really well. These are sorted binary data. All right. Okay. So whenever we are storing a table into HBase, tables are automatically partitioned horizontally, meaning from starting of one row key to another row key will go into one region, while from another row key to some other row key will go into another. So basically that's how the regions are created, and each region contains the table's rows, a subset of table rows, and a region is denoted by table name is first row, which is inclusive, while last row is not included but is mentioned in the region definition. Okay, so what happens is initially there'll be a single region. When you start creating a table, it'll have a single table, and as and when you are adding data, so table is increasing, right? Table is increasing horizontally, and the moment it reaches a threshold, that threshold you can define in terms of the size of the table, not in terms of number of rows, in terms of size of the data. The when it reaches a certain threshold, it splits into two parts. Okay, it's like having a big bubble. If you keep on increasing that big bubble, it splits into two, and then both of these bubbles can be increased parallelly and they will keep on splitting. So there was another effect we used to call it. I forgot the name. So when basically, so yeah. So the way I'll just show you. So there is this nice little table, and in the beginning there are only these many records. Now after some time it is start you added there were one row, two row, three rows, and then you added more and more data to it, and yeah, and you kept on increasing the table. Okay, it became really big. Now at this point what will happen is it will split into, you added a more records into it. Okay, now what will happen is it will suddenly in split into two parts, uh, say this one and this one. Okay, so it became into two parts, and again if both of them keeps on increasing they will keep on splitting, and so on. Okay, and this table will move on to another server now. Okay, this was server 1, the region server 1, and this will be region server 2, region server 2. Okay, and further they keep on expanding. They will again burst into two and then will move on to other machines. Now what you would notice is the load balancing is automatic. We do not have to keep on load balancing ourselves. It will automatically keep on doing that. Okay, And in a long run, this is how the structure of system will look like. So basically, if you have your row key starting from A to Z, first region server might contain the data from T to Z. First region server is containing two regions from the same table. One region is T to Z, other region has keys from A to C, and so on. Okay, is this diagram clear to all of you? All right. Yes, each region server is a separate machine. In our case, you can see that there are these three region servers and they are running on these three different machines. All right. The architecture is that there is something called master, which is called H-base master. You can see here that there is something called active H-base master and there are region servers. Okay. And in the configuration, you will see that there will be a threshold on which it will split the data. Okay. All right. Yep. So in our LED, we have four machines. In our lab, we have four machines. Out of these four, one is a master. That's correct. Okay, that's correct. And other three are region servers. That's how we have installed it. Okay. We can also say that on this host, we can basically remove region server from one host, and we can say things like action and region servers, and we can say decommission. Okay. So that way, one region server will go down, and the data from that region server will get transmitted to other region servers. Okay. All right. So in this diagram, you can see clearly it's exactly like our rest of the architecture in Hadoop, where there is name node and data node. Similarly, there is master and region servers. And interestingly, to keep the whole thing going, master and region servers use a third party to communicate. Instead of master and region server talking to themselves directly, they talk through a party called zookeeper cluster, zookeeper. So whenever region server comes up, it informs zookeeper, hey, I am up. While and when master keeps on looking at zookeeper to know which are region servers are up. So as and when you are adding more and more region servers, they as and when they come in, they just mark their attendance at zookeeper, and from zookeeper, master will come to know. Okay. So that is how the communication in today's time happen, because it's very difficult to have the concurrency running if the machines go beyond certain numbers. We will discuss reasons of zookeeper a little while later. And the other thing which you should note is each region server is storing the data in HDFS. Yes, Kalyan, that's correct. All right. Now, the physically, whenever you create a table, it stores here. Let's have a look at it. Okay. Let's have a look at it. And so Hadoop, let's go to Hue, and there you will see the file manager. So the data is stored at apps hbase data default. Okay. You can directly jump to that location quickly. Alright, so you can see that here is our table which we created today, and we are in HDFS. So under crawl corpus, these are the description of the table, okay, and it contains the some information like the compaction factor and all other information about the table, okay. And this is the file that contains some data. For each region, for each region, a file is created. Okay, this is our region server ID. As and when more and more tables are getting created, more and more such folders will keep on coming here. And under each region servers, there are two folders, one for each column family. If a table contains 20 column family, each column family will contain each column family will have a folder here. Okay, but I'm wondering where is my data. This is right? Did we delete this data by any chance? Or there is something else wrong? Hadoop fs-ls. Yeah, ideally it should have this data. I'm just wondering where did it store. But for sure, it stores here only. If you have another tables, you can have that in the family. You can have these files. These kind of files would be there for each database. Okay. I'm just wondering, are we looking at some other tables? All right. So yeah, so the data is actually stored like this as we have described here. So first is our this folder. Under that there is a table name. Under that there is a region ID. For each region there is an ID generated. Okay. Under each region ID there will be a folder for column family, and then there will be a store file. Okay, then there will be a store file. Maybe now it has created because we have exited. Yeah, now it has created. Basically, it was in the some cache or something. Okay. So under anchor, you have this data. These are our anchor names. You can see that in the binary form. And under contents column family, we created content column family. This is the data. All right. So basically, what am I trying to say is that whether it's Hive or HBase or any other, everybody uses HDFS to store the data. Okay, and the affinity we talked about, that all the columns of a region servers are close by. That means that they are in the same folder, and sorry, for each column family there are going to be a store file, right? A single store file, which means the data for each column family is going to be in the same table. Okay, same file. Okay, same file, and that too, the data will be in the form of column oriented fashion. Sorry, the data will be in a normal, like, row oriented fashion, not column oriented. Okay, so makes sense to you now? Does it make sense? Because for each column family there will be going to be one file. Essentially, that means that all the data for that column family is going to stick together. All right, while the data of another column family will be in another HDFS file. That means it's a different place altogether. All right, this we have talked already about. Like, row updates are atomic, no matter how many columns are there. Uh, the row label transaction is always there, and this basically helps in the performance and makes it possible to have locking. If we try to have multiple rows locking, that will be very very difficult and will defeat the purpose of high performance databases. All right, so okay, should we take a break for 10 minutes? So, all right, I'm back. Should we start now? All right. So, great, great. So, we talked about a general data model and a bit about how to add the data. Now, when we are retrieving the data from HBase, it does not provide you a great SQL query. It does not provide you the select statement. It provides you a very rudimentary system. Okay. And there are very valid reasons for it. Because first, there are third party tools like Hive. They provide you a proper select queries. Second, things like join, order by, and all those things, they are provided by the way of MapReduce. Okay, and those joins are generally not possible by the database itself. Those are done through our usual MapReduce. All right, so that's where the HBase plays a role. Okay, now HBase provides you something called scanners. Scanners are like your usual cursors of databases, which basically represent a pointer to the result set or a reference to a result set. Okay, so you have to be they have to be closed after the use. Once you have, so programmatically you will always create cursor or scanner to get the data. And when we are uh, uh, getting the data using a scanner, we basically define three things. First, on what row do we want to start at, on what row do we want to stop, and which columns to return, and maybe a small filter that we need to run on the server side in order to avoid certain rows. Okay, out of these rows, if we want only few rows to be selected, then we can say that when the value matches this, only then you return. Okay, so this is how you retrieve the data. So the data retrieval is done through the invocation of scanners. You create a scan. Scan parameter is defined as the starting row, ending row, and optionally what filters to run, and optionally what columns to return. If you do not specify columns, it gives you all the columns. Now each invocation of next, whenever, so every scanner will end at every scanner will stop at a single region server, but you have to invoke next in order to trip back to another region server and get the data. Okay, so that's how the retrieval of the data from HBase work. And we have already gone through this example, and so we talked about till here. And till here you can say describe corpus. So where, yeah, describe, what was that, what was the name, crawl corpus, crawl dash corpus, to see the details about. Okay, so it shows you the all the information about this table. And all right, next is, if you want to delete this table, you can say disable, disable. So deletion is a two-step process. You disable first and then you delete it, and then you drop the table. Clear to you? To see the status of the database, you can look at this URL and see what's going on with your master server. Okay. Okay, it shows you all the details about all the tables. I'm just wondering how come my table is not there in this. This is strange. All right. I don't know how come my tables are not there in this. This is crazy. Never mind. So we'll check that later. Oh, we have dropped it because we just dropped it. That's the reason it's not there. Okay. Now going back. Now, so if you are from Java background, probably this would make sense to you. Although it's nothing but whatever we have done through the command prompt, it's a similar thing. So we first create a config object. Using config object, we create an admin object. After that, admin object is the handle with which we will create the tables and other thing. Then we create a table descriptor, meaning we define a table with the name test. And here we are adding columns. We are creating column descriptor and then adding this column descriptor called HCD to the table descriptor. So we are adding columns to the table and then we are telling admin to the create the table. Basically, we are telling the column family, we created column family, and then we created the table. Okay. And once we are done with that, we can list all the tables using admin handle. And using admin handle, we can also get the data from each table. Okay. So the way we are doing here is so yeah. So this way, basically, the API it provides is very rudimentary, get and put and those kind of API. Okay. So basically, the you will be defining whenever you are retrieving that, whenever you are creating a table, a Hive table on top of HBase table, you will be defining your columns again in that Hive. Okay, the way we define the table names while we retrieve the data from from HDFS, we define the column names. Similarly, while creating our table in Hive, we will be defining a table structure on top of HBase. Okay, and HBase will try to cast the data. In case it is not able to cast the data, it will give you an error. All right. So okay. Next is that similar to the way we were running MapReducer on HDFS, in the similar fashion, we can run our MapReducer on top of our HBase. Okay, the syntax is similar. The only thing is the record definition is very clear here. So you don't have to define an input split, or you don't have to define that how is my record going to be prepared, because here each row is a record. So to your mapper, whatever mapper you create, at one time you will get as an input a record as the value, and the row key as the key. And basically running a mapper reducer on top of HDFS table, HBase table is the way forward for doing a complex processing of the table. All right. So you create a mapper like this, extending table mapper. Okay. And once you have done it, you create a reducer, extending table reducer. And almost syntax is the way we have defined earlier also. Once we have done it, we basically stitch it together and then run it. We create a config object, we define a job, and when define all of this, and then we say that table map reduce util dot this is my job description, and then we run this program, and it will basically launch your mapper reducer. Okay. So if you are so ideally you can also run a normal HDFS normal mapper reducer also by defining a different kind of input split. Okay, but this one is little more efficient when it comes to churning data at HBase. All right. Now there's something called Bloom filter. So whenever we are searching data in HDFS or HBase, whenever we are searching the data in HBase, and we are specifying, we are looking for particular row key. So when we are looking for a particular row key, it looks it uses Bloom filter to look for that data. We'll talk about Bloom filter in a minute. So whenever we are looking for some data in HBase, it will internally search for that particular key. Although you do not have to enable, disable, or configure Bloom filter. Bloom filter is by default enabled on HBase, and you don't have to generally interact. The only reason why I have kept a Bloom filter, because Bloom filter is a terminology, and as a strategy is used at a lot of places, and is also asked in many interviews as well. It's a very common question people ask, although you won't have to configure anything. Okay. So has anybody encountered this term earlier? Anyone? No. Okay, good. Yeah, although it has nothing to do I mean, you being a developer, you won't have to configure it or do anything about it, but lots of people keep on asking this as an interview question. Reason being, it is used as a strategy at lot many places. When you design or structure systems, you use this as a strategy, and you will understand this uh, after this discussion, that this is actually a quite an important strategy when it comes to big data. Okay. All right. All right. So yeah, I will try to draw something, scribble something as I describe. Okay. All right. How do I get out of the? All right. So let me try to draw. So let's say there was a person, or there was a watchman. Okay. He so everybody, all the users will basically come to him and ask, am I in the list? Okay. Am I in the list? Okay. So there are so many people who are asking him the same question. Okay. And now he looks up in the records. There is a huge record set. There is a huge record set. It keeps on looking at it and then keeps on responding to them. Okay. So for each one he has to do so much of work. Okay. Now, now he says that I am actually overloaded. Can we do something about it? Okay. So somebody said that let's split this data into two sets. Okay. And on first set you work, and on second set other people will work. Now these users who are coming in, they wouldn't know who to ask. Correct. And whenever there is an update happening, you'll have to update all these records. Okay. So the strategy which is generally devised is something called a Bloom filter. So what happens is there is a primary desk. Okay. And there is a uh, so what the in the new way we have hired a new watchman. Okay. A new watchman here. So what he does is he has a list of only the surnames. Only the surnames. Okay. Only the surnames. Or you can say that it has a list of first two characters of each name. Okay. So this list, how big would that list be? So we prepared another list out of all the names. Instead of keeping all the names, we are just keeping the first two characters in this new list. So how big that list be? Anybody? Yeah, Vikas? 26 by 26. That is correct. Yes, it will be very small. So that will be 576. Correct? So it'll have only 576 records, while the actual number of records will be too many. So the reason why, basically the problem statement was that our existing watchman was very busy in looking up for the records. So what he suggests that most of these people who are coming to ask me that am I in the list, most of them do not exist in the list, right? If we can just avoid those false positives, if we could avoid those kind of people whose name is not in the list, it will be great. So what they do is they create another list just containing first two characters of the name, and then in the beginning all of these people have to come to first this. So basically all of these people will have to come to first this. Okay. 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 And in case they are found in this list, only then the real lookup happens. It's like preliminary lookup. Okay. Now let's come back to this diagram. So This filter, the first filter is this new guy who we hired, containing only two characters out of their name. So a user will come in. So user will come in and ask, "Hey, I am in the list." He will immediately say no. If he says no, it will definitely be sure that he doesn't exist in the actual list as well. If he says yes, that means he may exist. If he say no, that means definitely he's not there, right? But if he says yes, that means yes means that okay, your first two letters are matching, but I think we should let me confirm it from the main guy. Okay, if somebody's first two letters are not matching, it will immediately say, hey, we don't even have people with those initials at all, so you just go home, we don't have your name in the list, right? So this is Bloom filter. In our case, the logic we used for generation of the key in the Bloom filter was first two characters. This logic of generating Bloom filter could be as complex as the key for Bloom filter. It could be as complex as like sum up all the characters and then divide by 26, and whatever is the remainder is the code. Okay, so all right. So basically, the way the Bloom filter is structured, that the key should be sufficiently big, and so that there are less of false positives. This is false positive. Okay, where filter said yes, our Bloom filter said yes, but in actual storage the data was not found. Okay, so this is our false positive from the Bloom filter side. And so to minimize Bloom filter, if we have just first characters, there are very high chance that for every request we have to send for the storage verification, right? The the I mean the significance of Bloom filter will get reduced. Our key is very small, okay, and the significance of again, if you have key really big, okay, that means then Bloom filter will also be equally loaded as actual storage. Therefore you generally choose your Bloom filter key very responsibly. Okay, so I hope I'm able to explain Bloom filter to you. No, feel free to ask question, because this is something I would like to describe. So Vikas's question is, but this can be used anywhere like MapReduce. Yes, it could be used anywhere, not only not only in this. It's basically a data structure. It's an algorithmic technique. Okay, in your web application you can design in the similar fashion. All right, so is my voice breaking for others also? All right, so is Bloom filter clear to all? Okay, all right, all right, so let me describe it again. All right. Now let me describe it again. So there were actually storage. So there was this huge database containing billions of entries. And whenever user request comes in, it tries to search there in that index. The index itself, in mostly in the big data cases, index itself is really humongous. Okay. So looking in at, so the index itself is humongous in most of these cases. And whenever we looking up in billions of rows, a better technique is to create a pseudo index, as in a smaller list of values. So for 1 billion entries, we'll have just say 500 entries, or maybe 1000 entries. Okay. And how would we create, say, imagine this, we have got in the actual storage there are 1 billion names of people. Okay. 1 billion names of people. So what we do is we create something called a bloom filter, and we create this new index out of these big keys, such that imagine that we just picking out of a few billion entries, we are just picking up first two characters or first three characters of people's name. Okay. And that's what we are keeping in a separate register. So whenever a user is coming in, whenever a user is coming to ask that, hey, am I in the list and my name is this, we first compare these his first three letters, and if these three letters are found in this newly created index, then we check against the actual storage. Okay. This way we make sure that he actually exists in the database. Otherwise we just say that you don't exist. Okay. So that's what is happening here also. So Kalyan's question is that, and Vikas's question is that, how do we set this up? We don't set it up. For row key, it's by default enabled in HBase. Okay, when you are looking up for some row, it automatically looks up in the Bloom filter and then goes to the actual database. All right, and in case of HBase, we don't have to define the logic to generate the key for Bloom filter, but in otherwise you can use things like MD5 checksum or hash code to the generate the Bloom filter key, right? So Aruna's point is that it's similar to setting up an index to speed up search. In some way, yes, but the difference in index is that index will just contain the deduplicated uh, unique list of values which are ordered, right? An index of a book is all the unique list of words found in the book, correct? But in case of a Bloom filter, the list is the trimmed down version of each word, maybe first two letters of each word, and so on. Okay. So that our preliminary search is really fast. Okay. Yes. So if cat and carrot would have the same filter key, good. Now once this matches, say cat comes in while carrot was the only one in the registry, then what happens is then the actual search in the index will happen. Okay. Otherwise the actual search will not happen. We'll just match the first two letters, and then if it rejects, then it rejects. If it says that okay, yes, cat has same initials as CA, Therefore, let me check in the actual database. Okay, that's what is exactly happening here. Do you have the key? So imagine that we have caret in the database. While cat is coming in, filter says, okay, yes, I have CA, but let me check. And then it goes to the actual storage. And then if the response generally the response will be here, let me check with the actual storage. It says, no, no, we don't have cat, we have caret. Make sense to you? I don't know. No? So it's a two-step process. It's a two-step process. It might sound like there is a too much of hassle, unnecessary, because there are two calls for false positive. We could have avoided those, but it's a trade-off. It's a trade-off. I mean, statistically, this will give you more benefit. If there are more false positives, then this will give you far more benefits. All right. So Aruna's question is, where will we use it? So anywhere where when your search engine is over flooded with the requests. Okay. Whenever imagine that even in the real world scenario, there are so many requests coming on your server, and you know that 90% of those requests are invalid. So you generally set up something which can immediately say no if it doesn't exist. Okay, if there are so many invalid requests are coming in, there are so many false so many negatives are there, so many rejections are happening on the server side, you generally set up a bloom filter such that those rejection can happen immediately. Okay. Yeah, so as I was telling you, bloom filter per se you don't have to configure in case of HBase. It's already configured very well for row key. But it's a general concept which people enjoy asking in interviews. That's why I have described. In general, if you are building your own system, and and if you're building your own system, then you can uh, build your own bloom filter algorithm, or there is a library of bloom filter which you can use in order to make it really really fast to reject. Okay. But in case of Cassandra, we have to enable it externally. All right, you must have seen here when I said scan, it would say that a bloom filter is per row. You can see that. So whenever we'll say that get me all the rows starting with this row key, it will first check in the database. It will first check in the bloom filter whether that row key exists or not. Otherwise, it'll give immediately zero results. Okay. All right. Moving on. Now there's an idea called coprocessors and coprocessor. So each table, of course, Aruna. So whenever we are saying get me the row with this row key, it will basically first check in the Bloom filter, and then it will check in the actual data. Yeah, internally it's defined per table. Okay. All right. Great. Now the other ideas, just like our triggers in normal database, we have other idea called coprocessors. Coprocessors are the functions which gets which gets called when the user is doing something on your database. Say, for example, we can define something called pre-get or post-get. Similarly, we can define pre-put and post-put. So whenever user are trying to retrieve a particular key or trying to retrieve any key, your coprocessor will get called. Pre-get will be called when before returning the value to the user, while post-get will be called just before the user is receiving that. Okay, so pre-get means the get has started. So whenever you have to more, so coprocessor enables you as a developer to put various kinds of filters or the filters or the processing into the database side. So for example, if there is a user who is accessing the table and you do not want particular rows to be accessed, you want to give an error to the user. So what you can do is you can say, you can define a pre-get coprocessor, and in the pre-get coprocessor you can say that, hey, if row equals to this, then do not return the value. Okay, and so on. So just like your triggers, you can define coprocessors in HBase. And once you have defined this class, you can compile it, create a jar, and you can basically put the jar in the libs of HBase, and in the HBase config, you can define in this particular XML file, you can add this property called property here in this HBase config. Okay, that this is so in there will be already a property called reason classes. You can put one more here in the comma separate. If this property does not exist, add this into this XML file. Okay, so basically this way you can put various kinds of triggers, or you can control access, you can do anything, any security control you want to do, you can do using a concept called coprocessor. All right, so once you have to, you copy it to the reason server, and the problem with this approach is that you will have to copy to all reason servers and then restart. Okay, the other way could be, that you basically put the jar inside a table and mark this table as this particular row as coprocessor, and then it will be executed. Okay, this way, the second way is easier, where you are putting the whole code inside the compiled code into the table itself, and which mm, which is understood by HBase. All right, next is that other than providing a shell interface, a Java interface, HBase also provides you a REST interface. What is a REST? REST is basically accessing the values in the form of plain text using a URL. Okay, so whenever you call a service using a URL, it returns certain value. All of this is called a REST interface. Okay, but in case of REST interface, whenever we are trying to retrieve the values, we try to specify everything as a part of our URL instead of passing it as the header information or any other information. Okay, so in case of REST interface, we provide all the things, all the parameters in the URL, and the server responds with the details in the plain text. Okay, the text could be in JSON, the text could be plain text, the text could be in XML. It is up to the service provider. But here in case of HBase, you can the kind of values it returns is in the JSON format. Okay, so it's a standard definition of REST interface where we call a URL and it gives us some value. And the definition of URL starts with a scheme, and then we have authentication details. Scheme colon slash slash scheme could be HTTP, FTP, HTTPS. Scheme could be, uh, there is HDFS colon slash slash, and so on. And then comes the authentication detail, login and password. If you use a FTP, you could have used this already. And then you can define the port number, then path. After that, there are parameters. Okay. So in the similar fashion, here, whenever you are calling, you can basically start HBase's REST service and do whatever operation you want to from the URL itself. This makes it is a quite useful thing because you can include this full path into the JavaScript, into your page, and make it possible for people to include the data into their charts. Say for example, D3JS requires all the data into JavaScript. In case of D3JS, you can include this URL and it will get the data from that URL directly into your web page and then present it. So you can start a REST interface like this. Okay, and then access the details here. Okay, so whatever table you have, you can specify table name, row ID, then column name. It will give you the column values. All right, this is how you generally access the data. Also, you can put the data for using the REST interface. All right, so this is the most simple client interface to to access HBase remotely other than our HBase service. Also, there is a JDBC driver which is called phoenix.apache.org, and then using this you can talk to HBase as if it's a JDBC driver, uh, as if it's a database. It's a relational database. So, all right. So if you are coming from a relational background and you want your Java code to be accessing as if it's a Java JDBC kind of interface, or you have rows, columns, and usual stuff, then using this driver will help you. Okay. Any questions for me? Any questions on HBase? Yes, Aruna. If you have any questions related to anything, right, you can write to Hadoop at No Big Data or reach us. Okay. So no questions on HBase. Okay, then moving on. So REST or JDBC, you will use it when you want to access HBase programmatically. Okay, whether different system or the same system. But when you run this, you will use these APIs from programs. Okay, great. All right. So now we are discussing a very important aspect, which is Zookeeper. Just like HDFS, Zookeeper is also an independent service on which everybody else depends. To an extent, HDFS itself depends on Zookeeper. So we'll be having a discussion on different technologies at the end of the course. All right. In session number 10, you can go through the session number 10's video also. There is a recorded video if you want to go right away. You want to watch it maybe after this session. All right. Now coming back to, so in the beginning when we talked about what happens when name node fails, how would users discover, how will how will our clients discover that what is our new name node, and and so on. If data nodes are down, other new data nodes comes in, how will they discover? Okay, so there are many scenarios where a coordination is required between client and server and masters and slaves. There's a lot of coordination required. For example, let's take this case. In this case, imagine that there is a single inbox which is being processed by multiple email processors parallelly, and these email processors are running on different machines. Now, what do we want is we want these email processors to coordinate with each other so that they do not process the same email. Okay, if one email is being processed by one email processor, then second email processor should not process that particular email. Now how do we do that? Okay, now imagine that this inbox does not allow us to put labels or make some modification. It does not provide us any modification or anything. All it provides us a unique ID of each email. Each email has got unique ID. Now, how would you do the coordination? How would you ensure that these email processors do not process the same email? So, anybody? How would you generally do this kind of thing? Had these email processors been different threads, we could have used the thread construct from the language. Say in Java, we have thread construct locking constructs. Had these been separate processes on the same machine, we could have created a local file. Now these are three different s- servers. These are running on three different servers. In these kind of cases, they generally have to have a central database. Using this database, these can coordinate with each other in order to avoid conflicts. Okay, so the way it happens is that there'll be some separate database in which each email processor will mark that this is my under processed data. Okay, do not touch it. And before another email processor starts processing, it will check in the same database and find out whether this particular email is being processed or not. Okay, so you can see that this particular whiteboard, you can see that it's like whiteboard where everybody is writing that what they are doing, and before starting to work on something, they're checking against this whiteboard whether whether this particular thing is being done by somebody or not. Okay, it's like having all these people sitting in a room and looking at a whiteboard. Okay, and whenever they start processing or they start calling a customer, they write it down on the whiteboard so that two people do not call the same customer. So such coordination is everywhere. Such coordination starts with data node name nodes, where name node has to discover which are the data nodes, and data nodes need to discover that who is our secondary name node and who is our primary name node. Is primary name node down, then they will all send requests to the secondary name node. So this coordination amongst various services running on multiple hundreds of machines is is very much required, and that's where the zookeeper comes into play. So zookeeper is basically a distributed service, meaning a service which can be used like a central database. The only property of this zookeeper is that it is heavily distributed, meaning zookeeper itself, this whiteboard where everybody will be writing things so that they can coordinate, this whiteboard is actually running on multiple machines parallelly, and the way it runs is very stable, in the sense that it cannot go down so easily. Okay, and the mechanism by which it runs is very important, is based on a algorithm called Plaxo. Okay, Plaxo's algorithm, we'll talk about it when we go ahead. Now the zookeeper itself is running on multiple machines, and then people are asking using zookeeper like a white as a central database to resolve their coordination problems. Okay, so a zookeeper is, other than being distributed, it is very simplistic, extremely simplistic. It's like your file system, in which you can create a file, and there's a tree, there's a parent, and there is a child. The only difference is, in this tree there are only nodes. There's no such thing, there's no distinction between file and folder. Okay, each node can have some data, and each node is a parent of somebody, and each node can have further children, and each node has a parent, and by default there is a root folder. Okay, so it's great. It provides you a data model like a directory tree. Okay, it provides basically a tree structure to you to store the data, and is used for synchronization, configuration, maintenance, and it does not suffer from race conditions or deadlock. Race condition is when two programs are competing with each other parallelly in order to access a resource. That is called race condition. It's like two people accessing the same bank account in the same using the same ATM card. Okay, imagine having two ATM boxes inside a ATM cabin, and one person inserts a card in one ATM, then takes it out and inserts it in another, and parallelly you are trying to withdraw the cash to confuse the service. Okay, so that if there are race conditions, there are chances that you withdraw the money and one of the withdrawal may get ignored if there are race conditions. So this is a classic case of race condition which I gave you just now regarding ATMs. If you think about it, and if you try to design such kind of system, 90% of the program in the world suffer from race conditions. Every shell script suffers from race conditions. Okay, similarly deadlocks are very difficult to avoid. Deadlocks is when A waits for B, B waits for C, and C waits for A. So this is a deadlock. All right. So any doubts about this? Any questions? All right. So the design goals of zookeepers were pretty simple and are very consistent. It's a shared hierarchical namespace. So as I was telling you, if your system is on the same file same machine, you can use the file system for coordination. You create a file and tell all others that this is the file I'll be creating. If you see this file, you do not process anything. You just wait for me to finish. Okay, so that's coordination. In the similar spirit, you have this zookeeper as a hierarchical namespace that looks like a standard file system, and instead of files or folders, will have only nodes. Okay, so there is a root node slash, and then then you can create nodes inside it. Each node has data, and each node can have further nodes, and these nodes are called z nodes. Okay, and data is kept in the memory, most of it. Okay, and this way, so partially the data is kept in the memory to give you really high throughput, and is used in humongous systems when you have thousands of servers running parallelly to cater to the customers. Then zookeeper is the only way forward. Okay, because it's highly available. I'll show you how it is highly available. And then strictly ordered access, as in there is a huge synchronization. Okay, next is that it's replicated. All right, it is replicated. So the client keeps the TCP connections. So the way it happens is that, so first design goal was very having the whole database is very simple. Second design goal was having replicated. What does it mean by replicated? It means it should run parallelly on multiple machines. In case one machine goes down, there are other machines which have the same data and are immediately available. Okay, there is no requirement of manual intervention at any point of time. So the client, the user of our zookeeper, would keep a TCP connections, will keep on sending the heartbeat to a system, and if the connection breaks, he will switch automatically to a different server. And all these machines you see, these machines know each other. There is one guy called the leader, and there are other guys who are called the followers. Okay, and each of these servers keep the in-memory image of the whole state, and transaction logs as well as the snapshots are the only thing that are kept in only the disk, not in the memory. Okay, and whenever an action happens in zookeeper, it marks it with a number which is used for transactions. It's really fast. At Yahoo it was benchmarked for over 10,000 operation per second. All right, so you can check whether it is up or not using these four letter commands, and the way you can basically test whether it's running or not, you can say echo are you okay, and we say SSH, or say NC. NC is just like SSH, which basically connects you to a particular machine on a particular port. So it immediately says I'm okay. See that? And you can also check, yeah, you can also say status, and it'll tell you all the details about the servers. So this way, these are few administrative commands. Now, the way you install is by downloading Zookeeper from there, and you can just start it this way. This is okay, but this will only start in a individual mode. If you have to set up the full cluster, it takes a little bit more effort. All right. So this is how typically the data model of Zookeeper looks like. There is a root node, there is a children. We can keep on creating as many children as we want. Okay, there is Zoo has duck, and Zoo has goat, Zoo has cow, and slash has zoo. So by default there is only slash. Okay, is the data model clear? All right, and each node can have data. Also, whenever you are reading or writing from this node, okay, either you read the full data or you get nothing. Either you write the full data or you write nothing. Okay, so that's the data access is always atomic. Similar is the data writing. Data writing is always full or nothing. Now there are two kinds of nodes. These nodes, do you see this? There are two kinds of node. One is persistent, which do not get deleted. Other is ephemeral. Ephemeral gets deleted as soon as the client who created that node get disconnected. Okay, so say you connected to Zookeeper, and after connecting you created an ephemeral node. Now your connection got disconnected. Your connection got lost. Okay, your internet is down, your connection is lost. This particular Z node which you just created, which the ephemeral node which you created, will disappear after some time of your disconnection. Okay, this way I can for sure say that these are the people who are online, these are the people who are offline. Okay, that's the use of ephemeral node. So if there are 1,000 data nodes and these data nodes have created their entry in ephemeral node saying, everybody, as soon as these data nodes are created in a manner that whenever they come up, they come online, they report to Zookeeper saying, hey, can you create an ephemeral node with my IP address? Okay, and this IP address is, I mean, this IP address will be visible to the other clients or the name node saying, okay, these are the data nodes available as of today. And as soon as a data node goes offline, disconnected, this ephemeral node gets deleted, and thus the it will not be visible to anybody. So this is a very great utility in order to create a fault tolerant systems. All right, now you can, so persistent node is the one which never gets deleted, and ephemeral node is the one which gets deleted as soon as you get disconnected. Okay, so let me show you. So this is, so Zookeeper client is connected. Now I can say ls. These are the child node of slash. Okay, let me create a node called 30 May. Okay, create 30 May, and I say some data. Okay, you have to start with slash. Okay, now we have 30 May. We can say ls 30 May. There is nothing under 30 May. Now, if I create an ephemeral node by putting -e, we can say 30 May and slash me. Okay, all right. I'm sorry. You have to, yeah. Let me just copy my previous command. Okay, you have to always put some data. So this is the data which this is my, this is data. Okay, so now if we say 30 May, you can see the data, you can see the node. Now if I disconnect and, okay, so you can say ls 30 May. After some time this me will disappear. Okay, after some time this me will disappear because the client has got disconnected. All right, it should disappear by now. Okay, yeah, now it has disappeared. Why? Because the client who created this node has disconnected. So this is called an ephemeral node. All right, the other third kind of node is sequential node. In sequential node, you do not you do not specify the full name of the node you are trying to create. You only specify the prefix. Okay, this prefix will be suffixed with a number which is being monotonically increasing in this particular folder. For each folder, the number starts from 1. Okay, so for example, here in this case, if we are creating sequential node under 30 May. Okay, we specify X. Again, I made a mistake. So we create a sequential node under 30 May with a name called X, and we put some data in this. So you can see that a node with the name 1 suffixed to the prefix we specified is created. Again, it will create 2x. You see that? So now, can somebody answer to this? Now, what will this create? Anyone? What will this create? Kalyan, Aruna? Uh, okay, correct. Yes. So it will create this. Okay. It starts from 0, not 1. The previous one started with 1. Why? Because we had already created an ephemeral node under this node, right? Although that ephemeral node disappeared, still that is counted. The ID has increased. All right. Even if we delete all these nodes, even if we delete all these nodes, still Okay. Okay. Now again, if I try to create something the way we were doing earlier, the number will keep on running. Okay. So this is called a sequential node. Now your question could be that what's the point? What's the use of this sequential node? The use is at a very many number of places. Imagine that you are running a customer support portal for which every customer request has to be increased by one. Or parallelly, there are many such client like some document management system, resume management system. All of these systems require a new ID every time. So they can utilize Zookeeper Zookeeper to have the new ID generated, to have the new ID generated every time. Okay, make sense to you? So there we talked about three kinds of node: ephemeral, and also one more thing I forgot to tell you: ephemeral node cannot have children. Okay, although they look like a private node, but they are visible to everybody. Okay, and in case of sequential node, the name is automatically generated. All right, and you can provide an empty name as well, so you can say things like this. Okay, the name is the full name is generated as a number. All right, there are many functions such as create, delete, ls, get, access control list, get children. These are provided in the API. And all these operations, whether creating a node, deleting a node, and you know, listing the node, all of these operations can be batched together, combined together, so that you can create mini batches, the transactions over Zookeeper. So Zookeeper provides you the ability to create transactions. Although the basic API to access Zookeeper, other than the command prompt, basic API is in Java and C, but there are many API available which are contributed by people in the form of Perl, Python, REST. And for each function, the most important part is this is the only API where you will find this. For each function, there are two versions available: synchronous and asynchronous. Can anybody tell me the what is asynchronous? All right, I think we are already over 7 minutes. We will discuss rest of the things tomorrow. All right, correct. Thank you, Ingobin. Client won't wait for the response. So that till the project submission, you will have access to the Cloud Labs, Aruna. Okay. Let us know if you want to extend the Cloud Lab access. All right. Okay. Thank you, Diam. Thank you, Vikas. Thank you, Aruna. Thank you, Sandhya. Thank you, Kirti. Thank you, Kalyan. See you tomorrow. Thank you, Amish. Thank you, Basant. Thank you, Lingli. Have a great day. And we'll see you tomorrow at the same time.